We're supposed to find where this function is discontinuous. That means a place where the limit as x approaches some value. This is continuity. So discontinuity would mean these two are not equal to each other. Let's see. So is it that with piecewise functions, you really want to check these intersection points. Negative x equals -2 is one place where we switch, and x equals 4 is another place where we switch. So at x equals -2, the limit as we approach -2 from the left, that is going to be, I'll write out the notation. The limit as we approach -2 from the left is determined by this function here. So we can just plug in -2. -2 times 6 makes -12. -12 plus 1 makes -11. And the limit as x approaches -2 from the right is this function. So if you plug in -2, that's -10 minus 1, that makes -11. And now, so the limit exists. The limit is -11 as x approaches -2. Does the exact value exist? We need to plug in x equals -2, and if we do that, it's just the same thing as we got with the right-hand limit. The limit exists, so it's continuous at -2, not discontinuous. Is it discontinuous at x equals 4? Same thing, you want to do the left and right-hand limits, so I'm just going to use shorthand, the left and right-hand limits. The left-hand limit at x equals 4 means I can just plug in 4 into this function. 5 times 4 makes 20, 20 minus 1 makes 19. Now the right-hand limit means we're evaluating something a little bit greater than 4. So if I plug in 4, 4 times 4 makes 16. 16 times -6 is -96. -96 plus 115 is 19. So the limit from the left, the limit from the right agree. So the limit does exist. So this part, there is a limit, and we need to check to make sure that, check to see if we plug in 4, if it matches the limit. And again, if you plug in 4, it's the same as the right-hand limit. So it's continuous at x equals 4. So this one is none of the above. So this time we're supposed to find a value for k that makes this continuous. So this isn't really proper, but this is just because I hate writing with my mouse. We got a left and a right-hand limit, right? We need these two to equal each other for there to be continuity. And then we also need to make sure that, look, the switching point is at 3. We need to make sure that f of 3 is equal to all these things. So if you were to plug in 3, it means we have to use the bottom function. So -3 times 3 makes -9. -9 plus 13 makes 4. So the right-hand limit is something we can directly find. If you try to evaluate the limit as x approaches, I'm a bad calculus teacher. You should be writing this out, Isaac. The limit as x approaches 3 from the right of this function. And it's dictated by this down here because that's when x can be greater than 3. So we can just plug in 3 because there's no sort of indeterminate form here. -3 times 3 makes -9. -9 plus 13 makes 4. So that matches so far, right? We need the left-hand limit to also equal 4. So we can find the left-hand limit by plugging in 3. By plugging in, by plugging in 3. So I plugged in 3 in for x here. Because the left-hand limit is when we get infinitely close to 3 from the right. So this is like 2.9 or 2.999 or 2.99999, getting infinitely close to 3. And we need this to equal 4. It needs to equal the same thing as the limit and as the exact value for it to be continuous. Okay, so again, we're evaluating the limit as x approaches 3 from the left. So we can just take this equation by plugging 3 in and set it equal to 4. What it's supposed to be for there to be continuity. And if you solve that, you got to square both sides, divide both sides by 3, so I get 16 over 3 for k. And you can check your work too. If k is 16 over 3, then this function becomes the square root of 16 over 3 times x. And if it's the limit as x approaches 3 from the left, then we can just directly plug in 3 in here. 16 over 3 times 3 makes 16, and the square root of 16 is 4. So this limit is now going to be 4 because we specified k. So two places that we switch in this piecewise function. We switch here. So at x equals 1, we want to evaluate the limit. Here's my cheating shorthand. The left-hand limit means we use this piece of the piecewise function. If you plug in 1 there, you get 9. And the right-hand limit approaches 1 from the right. We plug it in this function, so you get negative 3 minus 2, you get negative 5. Oh, it's discontinuous. X equals 1 because the limit from the left and the limit from the right are not the same. The limit doesn't exist, so we can't get continuity out of that. We want to do the same thing for 4. So let's do our left and right hand limits again. As x approaches 4 from the left, that's 16 times negative 3. That's negative 48 minus 2 makes negative 50. Limit from the right, if you plug in 4, that's 16 times, I don't know what that is. 16 times 7 is negative 112. So that's negative 108. That limit also does not exist. So these are the 2 correct options.